Bismillahirrahmanirrahim. Today we will talk about a very interesting subject, which is a CTO intervention. For our fellows and the beginners of doing or performing a CTO intervention, there are some tips and tricks and physics that everybody should know exactly how to deal with the guide wires, especially if it is dedicated for CTO intervention, and also the microcasters, and how the combination of guide wires and the microcasters could reduce crosstalks in navigating CTO lesions. So our presentation today titled by guide wires and the microcasters, crosstalks in SHIP and CTO-PCI. For everybody performing CTO intervention, we all facing a lot of challenges. We summarize these challenges in what's called APC matrix of challenges, where A representing angulation and torch velocity, P representing backup and support, and C representing calcium and disease. To facing these APC matrix, you should having your tools, or what's called a CTO toolbox. So one of these tools is the guide extensions and the guide wires and the microcasters, and then the scoring balloons or rotablation, or finally intravascular lithotripsy. For briefly, we will remind our fellows about the dedicated guide wires that we all use in a daily practice for dealing with CTO intervention. We have two kinds or two groups of wires: the workhorse wires, or low taper tip like filter and fighter and bandits, and the intermediate polymeric like Pilot 200, Gladius Radier, and the high tip load like Confianza, Hornet 14, and Warner. Regarding microcaster, we have two groups of microcaster: the sliding microcasters or fine cross, like fine cross and caravel, enhancers and supercross, and the rotational microcasters like Corsair, Turnpike, and Mamba. There are some properties that everybody should know about the components of the guide wires and how the different characteristics of the wires could affect our performance. One of these is the coating, type of coating of the wires that will affect the porosity, the design of the core where it will help for support and push and durability, the tip coiling where it will help for maneuverability, flexibility, and torque, and finally the shape of the guide wire tip for lesion entrance and navigation. Also, everybody should know exactly what is the composition and the structure of the microcasters. As in Asahi Corsair Pro, you should know what exactly the meaning of Shenga shaft and how this design is dedicated for king resistance and torqueability, and also for penetration force. Also for Teleflex Turnpike, how it is composed of 5 layers of structures, and one of these is the dual layer bidirectional coil, which adds kink resistance and torque. The second issue here in this presentation is the dual component interaction. This is the core of our lecture today. To start this talk, we should know some kind of definitions that will facing us in daily practice. One of these is the tip load of the guide wire. For everybody to know exactly what is the tip load test, imagine that you're having a wire and you're hanging it freely, and the tip is downside facing a balance. and you start to let it to touch these balance freely. At the time where the tip of the guide wire start to bend, this is the resistance, or what exactly measured by the tip load, and it is measured in this balance by the units of grams. So the tip load here is the at which number of grams that where a wire was really hanging and touching the scale of the balance and try to be bended. This is the tip load, and it is measured in grams. And as we know, we're having a very wide range of guide wires that we use in CTO intervention, and these different kinds of guide wires having different tip loads, and as we see here in the source rate is about 0.3 gram, and if we reaching to the higher stiff guide wires like Hornet 14 or Confianza Pro 12, it is exactly 14 gram force. So the second definition that we should know is the penetration force. And the penetration force is actually an equation. It is a component, it's two components, it's the tip load over the tip guide wire diameter. And as we know, the penetration force measures the ability of the wire to penetrate a lesion. And it is better measurement than tip load for comparing crossing over penetration wires like Confianza and Hornet. All things are equal, wires with smaller tip diameters will have higher penetration force. So if you're having a wire with a high tip load and a tapered tip guide wire, so the penetration force of this guide wire is higher than if you're having a wire with a blunt tip. So the tip load plus tapering means penetration force high. The second definition is the effective tip load, and as you see here is the effective tip load. It means a changeable tip load. So this effective is the acronym of the effect of the microcatheter on the tip load, or the effect of a microcatheter has on guide wire tip load. So this means that if you're having a guide wire with a well-known tip load, this tip load could change or increase by the effect of the microcatheter on it. So the effective tip load range means that imagine that you're having the distal 12 millimeter of the guide wire. And this 12 millimeter distance is a critical distance for every guide wire you use. If you divide this 12 millimeter distance into 6 parts, each part is 2 millimeter, so you're having now a scaled tip guide wire. So represent that or imagine that you're having a microcatheter tip reached the far distal 2 millimeter of the guide wire. At that time, this tip of the guide wire having the higher penetration force or the higher effective tip load range, where the effect of the microcatheter tip have a higher penetration force exerted on the tip of the guide wire. As far you go proximal from the distal tip of the guide wire by the distal tip of the guiding, you're starting decreasing the effective tip load. As we see here, you become at the 4 millimeter, it is lower than the 2 millimeter. If you have reaching to the far 12 millimeter proximal to the tip of the guide wire, you're having the actual effect of the tip load of the guide wire itself. At that time, the microcatheter having zero effect on the tip load of the guide wire. So at this diagram, if we take, for example, turnpike casters with different guide wires with different tip load, you will understand what exactly I mean. So this is called the combo effect. The combo effect is the effect of the guide wire and the microcapacitor together. Each other affect each other. So the combo is the effective tip load range. If we're having a turn-by capacitor with a low tip load with 2 gram force like banded guide wire, by the effect of the turn-by capacitor on it at the different distance from 2 mm to 12 mm, you will having a range of effective tip load starting from 2 gram force and may reach up to about 5 gram force. Also, the same will happen with the mid-range like rider guide wire with a tip load of 2 gram to 5 gram. This by the site at which the turn-by tip will reach from 2 mm to 12 mm distance, you having a range of effective tip load starting from 5 mm, 5 gram force to about more than 13 gram force. Also, if the turn-by is used with a wire guide wire with higher tip load, more than 5 gram force, so it may increasing the effective tip load and may reach up to about 33 gram force. So, by the effect of the turn-by with a different kind of tip load guide wires, you're having an overlap zones. So, to explain it more and more, if you're having a wire guide wire and you're having two kinds of microcasters like turn-by casters and caravel casters, if you are at the effect of the tip of the microcaster positioned at the distance of 12 mm from the distal tip of the guide wire, this is the starting or the free effect of the microcaster and the guide wire. So at that time, the wire guide wire was having its own tip load, which is about 11.8 gram force. If you're starting going far to the distal tip of the guide wire by a distance 2 mm, you will having an increasing in the effective tip load and may reach up to about 33 gram force for the turn-by casters and 21.2 gram force for the caravel caster. And as we see here, the turn-by is a stiffer caster relatively than the caravel caster, so it will increasing the effective tip load of the guide wire than the caravel caster. So here, with the different kinds of microcaster with the same guide wire, we having a different range of effective tip load of the guide wire. Another example, if we having a wire guide wire and having a Corsair Procaster and the turn-by LB, as we see, these two kinds of microcaster is semi-flexible microcaster, and I think at that time you will not observe a very big difference between two kinds of microcasters. So the starting effective tip load will be about 12.9 and reaching up to about 26.9 gram force for turn-by LB, while for the Corsair Procaster it will start at about 12.7 gram force and may reach about 26.4 gram force. I think there is a low difference between each microcaster. So understanding microcaster and guide wire interaction, this diagram will exactly see you how the microcaster exert different kinds of effective tip load change on the guide wire. If we're having a guide wire and a turn-by caster, if the tip of the microcaster positioned at the 12 mm distance from the tip of the guide wire, this advancing the turn-by caster increases the effective tip load approximately 2 gram per 2 mm from 12 mm to 6 mm from the wire guide wire. After the distance of 6 millimeter, the exertion force will be increased, jumping up to about to 35 gram force. So from 12 millimeter distance to 6 millimeter distance, there is an incremental increase by about 2 gram force for the moving of the microcaster. But after the 6 millimeter toward 2 millimeter, there is a very big jump toward a higher effective tip load of the microcaster. As we see here, 14.7 gram force added increase for the distance from 6 millimeter to 2 millimeter. Also here for turnpike LP caster, the same advancing turnpike LP caster increases effective tip load approximately 1.2 gram force per 2 millimeter from 12 millimeter to 6 millimeter from the wire guide wire tip, and after 6 millimeter toward 2 millimeter, there is a big jump for the effective tip load and may reach up to about 26 gram force. Also here, wire guide wire with the turnpike LB, as we see here, from 12 millimeter to 6 millimeters, there is 1.2 gram force effective for each 2 millimeter, but after 6 millimeter to 2 millimeter, there is a big jump for about 10.3 gram force. So effective tip load range comparisons, if we see here, microcaster impact on effective tip load range for Teleflex guide wires. Teleflex guide wires, as we see here, it is a banded guide wire, rider and warrior guide wires. Banded is a low tip, rider is a mid tip, and the warrior is a heavy guide wire. With these three types of guide wires with different microcaster, you will see a very wide range of effective tip load. The base here, if you're having a heavy guide wire with a heavy or a stiff microcaster, you will having a very big range of effective tip load, may reach to about 35 gram force. And if you're going down with a very floppy guide wires with a very flexible microcaster, you're having also a variable range of effective tip load with a lower range of effective tip load ground forces. Also, if we're having a very heavy guide wires like Warrior or Hornet 14 or Confianza Pro 12 guide wires with different kind of microcasters, you will having a very big range of effective tip load with higher levels of ground forces, me reaching to about 35 with heavy microcasters or heavy guide wires with stiffer microcasters, and also it will be a middle range if you're having a low profile microcasters. So as we all know that these crosstalks and this changeable range of effective tip load is exerted by the combo effect of the selected guide wire and the selected microcast when or during negotiation of the CTO lesion. So finally, our key takeaway is that microcaster choice at less than 10 millimeter from the tip of the guide wire increases impacts the effective tip load of the guide wire. Advancing the microcaster from 6 to 2 millimeter distance from the guide wire tip dramatically increases the effective tip load of the guide wire. The effect of interaction decreases with softer microcasters. The interaction and absolute increase in its tip load is the highest with the high tip load wires. And finally, thank you.